Imagine this, an asteroid, a giant rock from space, hurtles towards Earth. It's not just any asteroid, it's a massive one, capable of causing unprecedented destruction. As it speeds through the void of space, it becomes clear that its target is our planet. It crashes into Antarctica with terrifying force. The collision is so powerful that it sends shockwaves across the continent, shaking the very foundations of the ice. The impact is catastrophic. It doesn't just leave a crater. The force of the collision shatters the ice, sending massive chunks flying in all directions. The landscape is forever altered. It unleashes a wave of heat so intense that it begins to melt the ice, all the ice. The heat generated by the impact is unlike anything we've ever seen, causing the ice to melt at an alarming rate. This scenario, while hypothetical, forces us to confront an unsettling question. What if all Earth's ice melted? Imagine the consequences of such an event. The ice that has been frozen for millennia suddenly turning into water. What would happen to our planet, our cities, our way of life? Coastal cities would be the first to feel the impact. Streets would turn into rivers and buildings would be submerged. The infrastructure we rely on would be rendered useless. This essay explores this chilling thought experiment. It delves into the potential ramifications of such a catastrophic event, urging us to think deeply about our planet's future. We'll delve into the science behind melting ice and rising sea levels. Understanding the mechanisms at play is crucial to grasping the full extent of the potential disaster. We'll focus on the potential impact on Melbourne, a vibrant Australian city vulnerable to the rising tides. Melbourne, like many coastal cities, faces a unique set of challenges in the face of rising sea levels. This journey will be a stark reminder of the interconnectedness of our planet's systems. The melting of ice in one part of the world can have far-reaching effects, impacting ecosystems and weather patterns globally. It will underscore the potential consequences of climate change. The choices we make today will shape the world of tomorrow. This thought experiment serves as a wake-up call, highlighting the urgent need for action to protect our planet. Before we dive into the numbers, let's clarify a crucial distinction: land ice versus sea ice. This is a fundamental concept that helps us understand the dynamics of our planet's climate system and the potential impacts of global warming. Sea ice, as the name suggests, is already floating in the ocean. It forms and melts in the ocean, and its presence is crucial for regulating the Earth's temperature by reflecting sunlight. Think of the Arctic ice cap. This vast expanse of ice plays a critical role in maintaining the planet's energy balance. When it melts, it doesn't directly change sea levels. This is because the ice is already displacing water, much like how an ice cube in a glass of water behaves. It's like ice cubes melting in a glass of water. The water level doesn't rise. This phenomenon is due to the principle of displacement, where the melted ice simply replaces the volume it had already occupied. Land ice, on the other hand, is a different story. This type of ice is found on continents and islands, and it has a much more significant impact on sea levels when it melts. This is the ice locked away in glaciers, ice sheets, and ice caps on land. These massive ice formations store vast amounts of fresh water. Antarctica and Greenland hold the vast majority of this ice. Together, they contain enough ice to raise global sea levels by several meters if they were to melt completely. When land ice melts and flows into the ocean, it adds to the overall volume of water. This process contributes directly to rising sea levels, which can have profound effects on coastal communities and ecosystems. This leads to a rise in sea levels, much like adding more water to our glass. Understanding these differences is crucial for predicting future changes and preparing for their impacts on our world. Antarctica, a continent shrouded in ice, holds the lion's share of Earth's fresh water. Imagine an ice sheet so vast it covers an area twice the size of Australia. That's Antarctica. This frozen continent holds about 60% of the planet's fresh water locked away as ice. Greenland, the world's largest island, boasts the second largest ice sheet. While significantly smaller than Antarctica, its ice sheet is still massive. If it were to melt completely, it would add about 7 meters to global sea levels. Add to this the ice locked away in glaciers and ice caps around the world, and we have a significant volume of potential water waiting to be unleashed. There's a crucial factor to consider when calculating sea level rise density. Ice is less dense than water, which is why it floats. This difference in density means that a given volume of ice doesn't translate to the same volume of water when it melts. The density of ice is about 90% that of water. This means that for every cubic meter of ice that melts, it adds roughly 0.9 cubic meters of water to the ocean. While this difference might seem small, it becomes significant when dealing with the colossal volumes of ice we're talking about. Section 5. A world reshaped, predicting the global sea level rise. Scientists estimate that if all the land ice on Earth were to melt, global sea levels would rise by approximately 65 meters. That's taller than a 20-story building. This number is a stark reminder of the potential consequences of unchecked climate change. This rise wouldn't be uniform across the globe. Factors like ocean currents, the gravitational pull of ice sheets, and the Earth's rotation would cause regional variations. However, the overall impact would be devastating, reshaping coastlines, displacing millions, and submerging entire cities. Section 6. Melbourne submerged, a city underwater. Melbourne, Australia's second-largest city, is a vibrant hub nestled on the southeastern coast. Its beautiful beaches and iconic landmarks draw millions of visitors each year. However, this coastal city is also vulnerable to rising sea levels. Melbourne's average elevation is a mere 31 meters above sea level. A 65-meter sea level rise would be catastrophic for Melbourne. Vast swathes of the city would be submerged, including iconic landmarks, residential areas, and critical infrastructure. The Yarra River would swell, inundating its banks and transforming the cityscape. The economic and social consequences would be immense. Section 7. A stark future. The broader implications. The potential submersion of Melbourne is just one example of the devastating impact of a 65-meter sea level rise. Coastlines around the world would be redrawn. Low-lying island nations would vanish beneath the waves. Major cities like New York, Shanghai, and London would face existential threats. The displacement of millions would lead to a humanitarian crisis of unprecedented scale. The loss of fertile land would disrupt agriculture and threaten global food security. The influx of salt water into freshwater sources would jeopardize drinking water supplies. The world as we know it would be irrevocably altered. Section 8. Adaptation or displacement, the difficult choices ahead. While the complete melting of Earth's ice sheets is a worst-case scenario, it highlights the urgent need to address climate change. The ice sheets, which have been stable for millennia, are now showing signs of rapid deterioration. This is not just a distant problem for future generations, it is a pressing issue that demands immediate action. The melting ice contributes to rising sea levels, which in turn threaten coastal communities and ecosystems. Even a fraction of that sea level rise would have severe consequences. Coastal cities, home to millions of people, would face increased flooding, storm surges, and erosion. The economic impact would be staggering, with billions of dollars in damage to infrastructure, homes, and businesses. Moreover, the social impact would be profound, displacing families and disrupting communities. Coastal communities around the world are already grappling with the effects of rising sea levels. From Miami to Manila, cities are experiencing more frequent and severe flooding. In some places, entire neighborhoods are being abandoned as the water encroaches further inland. The human cost is immense, with people losing their homes, livelihoods, and sense of security. Erosion, flooding, and saltwater intrusion are becoming increasingly common. Agricultural lands are being rendered unusable as saltwater contaminates the soil. This threatens food security and the livelihoods of farmers. Urban areas are also at risk, with critical infrastructure such as roads, bridges, and sewage systems being compromised by the encroaching waters. The choices we make today will determine the fate of coastal cities like Melbourne. Will we take decisive action to mitigate the impacts of climate change, or will we continue on our current path, leaving future generations to deal with the consequences? The decisions we make now will shape the world for decades to come. We can choose to invest in mitigation strategies to reduce greenhouse gas emissions and slow the rate of global warming. Renewable energy projects, reforestation efforts, and sustainable urban planning are all critical components of a comprehensive climate strategy. By reducing our carbon footprint, we can help to stabilize the climate and protect vulnerable communities. We can develop adaptation measures such as seawalls and elevated infrastructure to protect vulnerable areas. These measures can provide immediate relief and buy time for longer-term solutions. However, they are not a panacea and must be part of a broader strategy that includes both mitigation and adaptation. Or we can face the consequences of inaction, a world reshaped by rising tides. The choice is ours, and the stakes could not be higher. The future of our coastal cities, our economies, and our way of life hangs in the balance. It is up to us to make the difficult choices today to ensure a livable planet for future generations. Section 9. Our responsibility: preventing a catastrophic melt. The hypothetical scenario of an asteroid melting all Earth's ice serves as a stark reminder of the interconnectedness of our planet's systems. It highlights the profound impact that human activities can have on the environment. While the complete melting of Earth's ice sheets is unlikely in the near future, the threat of sea level rise is real and growing. We have a responsibility to act. We must reduce our reliance on fossil fuels, transition to cleaner sources of energy, and protect our planet's delicate climate balance. The future of Melbourne, and indeed the world, depends on the choices we make today.